Yes, science.
At some point.
You raise an interesting point. If I just gave answers, then you don't really need me.
No, you just be Black Google. Black Google. Neil the Black Google.
Right, so these are not Google answers.
Right.
These are sort of fleshy.
Exactly.
Notice, like, again, I'm just dating myself here. In the old days, when you look something up, you go to encyclopedia.
That's right.
But you never, it would take you an hour to get to the thing you were looking up.
Right.
Because you stumbled
all along the way.
That's
right.
There was a whole journey
Yes.
to find your answer.
And see, kids, this is what you're missing out on by not having an encyclopedia, because that experience you just said right there is one of the best things in the world. It is. You go look up in your world book.
Same with dictionaries.
Right.
You get lost. Oh, I don't know about that word.
Right,
Where'd that word
exactly.
come from?
Obstreperous. What the hell is that? Right? You know, and that's the fun of it. And this is kind of what we're doing. So,
Yeah. All right.
All right, here we go. Alex wants to know this. Alex,
I'm glad
Alex
you pronounced his name correctly. Okay.
Alex from Omaha, Nebraska.
I was just in Omaha, Nebraska.
You were where?
recently. Yeah. In
Cool.
Omaha.
Nice. Yeah, every time I hear Omaha, all I think of is Peyton Manning. Can a small
Really?
black...
Is
Yeah,
he from
because that's...
Omaha?
No, he's not, but he screams that out when he's at the line of scrimmage. He goes, 345, 345, Omaha!
Does he
Omaha!
really?
I swear to God, yeah. And I have no idea what it means in football or anything, but
Wow.
maybe somebody will write in and let us know.
Okay.
This is what Alex Betts wants to know. Can a small black hole orbit a bigger black hole? And if so, can it be a stable orbit where it would never fall into or merge with the larger black hole?
Okay, I'm going to be Black Google here. Ready? The answer is yes.
Boom.
Okay, next
There you
question.
go. Let's move on.
No. So here's the thing. I don't think a black hole knows it's a black hole.
Really?
It's just a lump of mass out there looking for love, okay?
That's why it's a black hole.
In all the wrong places.
Now I get the black part.
No. So the point is, so a way to answer that is, if Earth today turned into a black hole,
Right.
it'd be a mini black hole like the size of I calculated once, about of a plum. Okay?
Oh, really?
Yeah.
So you mean all of this Earth got down into
so
the size
our
of a
event
plum.
horizon, it would be deep within the plum.
Right.
But the plum is the size of our event horizon. Okay?
With the mass of the Earth.
Yes.
Holy crap.
Black holes don't play, dude.
Okay, so let me
They
ask.
don't play.
Before we go on further with this, I just got to, because you
What?
you just really
I'm in the middle of an
freaked me
answer.
out. I know, but
All right, what?
where's the space come from? So as you're collapsing, why don't you run out of space inside of what's collapsing?
Okay. You're wondering, isn't there a point beyond which you cannot compress it any further?
Yes.
Okay.
Yes.
All right.
Alex, we're getting back to your question. I'm sorry, but this
Chuck
is
just
really
inserted his
freaking me
own
out
damn
right now,
question.
and I just got to know.
Okay. So there are various states of matter.
Okay.
Okay. Why is a rock? Because something is preventing it from collapsing.
Right.
Okay. So what is it? Well, it's the forces between molecules and atoms.
Okay.
Okay.
Right.
So they're called electronic forces. They're called.
I got that.
Right. That's why we all have.
Right.
So
that's why I can't put my hand through my leg,
through your leg,
or through
okay?
this chair.
Correct.
Okay.
Correct. Okay.
I
Unless
got
you
you.
were Invisible Man or something, or some
Exactly.
other. What's the X-Men who could do that?
Oh
go
my
through
God.
walls.
Yeah, I forgot it.
I know.
I know who
Yeah,
you're talking about
All
too.
right.
But go ahead.
So all right. So now it turns out under high enough pressure, you can collapse that, okay, and close down the gaps that are between those atoms and molecules.
Okay.
All right. Now they get closer
Okay.
together.
Right.
Okay. And you get something called electron degeneracy. That's what it's called. It has nothing to do with its moral compass. Okay.
Gotcha.
Of electrons.
Right. Exactly.
Okay. Yeah. So electron degeneracy, they're so tightly packed, okay, that you're trying to cram electrons into the space of other electrons, and they don't allow that. All right. From quantum physics.
Okay.
All right. So they keep their own identity within the structure. And then we have matter out there that resemble it. It's called white dwarfs. White dwarfs are electron degenerate, and they're extremely dense.
Mm-hmm.
Okay? Wait a minute, you can go further. Okay? There's still the gap between the nucleus of an atom and the electrons themselves. Right. Let's collapse that gap, and that is the biggest gap of them all. Okay? You know what that gap is? Take a football stadium, okay?
Right.
And then put, I don't know, a mustard seed or something tiny.
Tiny is a mustard
poppy
seed.
seed. Mustard seed is biblical,
right?
But let's take a poppy seed.
All right.
Put that in the middle of the stadium.
Right.
That's the nucleus, and the outer sides of the stadium is the orbits of the electrons.
Wow.
Atoms are mostly empty space.
Gotcha.
And the first dude to determine this, his name was J.J. Thomson, and he performed the experiment by firing particles through a very thin film of gold. Gold, you can hammer it so thin you can have practically one layer thick of atoms. Okay, all right. It's very malleable, is the chemistry term. All right, make it really thin, and he fired particles, and he's ready to see them. Some bounce back, careen to the left, to the right, and 99.9999999% of them went straight through like nothing was there. Wow. And he was the first person to realize that matter is mostly empty space.
Gotcha.
And the next morning, he is rumored to be afraid to step onto the floor, getting out of bed,
right?
That he might fall through it.
Wow.
Because he alone knew how empty matter was. So the next stage is collapsing everything down, and you're cramming the electrons into the protons, because they're no longer can they separate themselves, all right? But they're not going to occupy the same space anymore. They're crammed together. If you combine a proton and an electron, what happens to the charge? It becomes what?
I don't know.
Proton. Thank you for that admission of total. All right, electron has a negative charge, and proton has a positive charge. They cancel out, and how much charge are you left with?
Neutral.
Neutral. So you put them together, you create a neutron.
Right.
Okay. So now you don't have the electron degeneracy, and you have a pack of neutrons. That is the densest matter that exists out there that is not a black hole. Okay. So these are called neutron stars. Because in my field, we tell it like it is.
Course, yeah.
All right. And neutron stars that rapidly rotate have magnetic fields. They pulse in radio waves. We call those pulsars.
Pulsars.
All
Okay,
right?
that makes sense.
The person who discovered pulsars, Anthony Hewish, won the Nobel Prize for it back in the 1970s.
And
60s.
started a watch company. Little known fact.
People always taking our words.
Exactly.
We got Milky Way candy bar. Excuse me. Can we get some royalties for that, please? Okay. The Mars bar, I know it's the family name, but still, I'm taking it.
Right.
All right.
Okay.
And you know how many car names are astronomically named? Cars? Okay. There's like the Astro. That's the name of a minivan.
That was oh my God, there is an Astro minivan.
Yes, I made a whole list. I got a whole list. We'll do a whole show
on
just
cars?
Car names.
Okay.
Car names.
All right.
A whole show.
All right.
I could do a whole show.
Okay, got you.
Don't get me started. Don't make me go there. Okay. A whole show on names of stuff that came from my field.
From your astrophysics.
Yeah, okay?
Gotcha.
Promise, we'll do a show.
Okay.
All right. So
now we're at pulsar.
Okay, now pulsar. That stuff is there. So that's, if you want to know how dense that is, take a herd of 300 billion elephants and cram them into a thimble.
Holy crap.
Okay?
Wow.
All right, so now you can calculate how much pressure that makes to stop it from collapsing further. And you can calculate that. And then you figure out, in a black hole, the collapsing force is even greater.
Damn.
So we don't know, we got no physics anymore after that.
Right.
So in a black hole, it's denser than the density of 300 billion elephants.
In a thimble.
Crammed into a thimble.
Right.
Okay? And just imagine trying to do that.
Yeah.
You know, with your...
Definitely need a crowbar or something.
Something. Push
Just
it in.
right.
So...
Wow.
Yes, I can get you to the neutron star density. After that, it's all black holes.
It's all black holes.
It's all black holes.
Wow.
All right. So now Earth becomes a black hole. We just continue to orbit the sun. The gravity between us and the sun is determined just by our masses. Our mass didn't change.
Right.
Okay. It's still the same mass. Who cares if we're a black hole?
Right.
All right. Now, if you turn the sun into a black hole, we don't care if it has the same mass.
Right.
So we're this mini black hole orbiting big black hole, and there you go.
Right. So we'd just be orbiting the little mini black hole. That's all.
No, we'd be the mini black hole orbiting.
Oh, no, I'm saying if the sun became a black hole, we would just continue to orbit that little black hole.
But we're littler. So we're the plum-sized black hole.
Right.
The sun
is the big black hole.
Bigger black hole.
Bigger.
Right. So So the point is, the reason why we see black holes have such high gravity is they have high surface gravity. But if you step the same distance away from it that you were before it became a black hole, there's not any
Nothing's
difference
going to happen.
Right. It's just that you can get real close to the center of gravity, and the power of the gravity keeps getting, the force of gravity keeps getting higher and higher and higher and higher and higher.
Okay.
So that's how that works.
That's awesome.
So the answer is yes.
The answer is yes.
We got to take our first break. When we come back, more Cosmic Queries.